In example 3C, notice that we now have every single transformation going on in our cosine graph. So the biggest thing that I want you to see is that inside this argument, inside these brackets, notice that we have our multiple in front of our x and then minus the pi over 3. This pi over 3 is not the phase shift, okay? Because if you remember from the beginning, you have to factor out this multiple that's in front of the x in order to get that phase shift. So if you ever see an example where that is not factored out, you must factor that out first. So we must factor out pi over 6 first before we can look at what the phase shift is. That's very, very important. So let's do that first. So we're going to factor that out. So this is going to be an equal equation. So this will be 6 times cosine of, factor out a factor of pi over 6 so that we can see the x, the single x with a coefficient of 1, minus, and then factor out that pi over 6. Remember, factoring is just dividing. So what we're really doing is we're taking pi over 3 and we're dividing by that pi over 6. So just for those of you who have trouble kind of seeing that. So we're taking pi over 3 and we're actually multiplying by the reciprocal of pi over 6, which is 6 over pi, which leaves us with just 2. Okay, so that's what we have left over in our parentheses is x minus 2, and then we have that vertical shift on the outside. So you can always check to make sure that you did it right, because if I then redistributed this back in, would pi over 6 times 2 be pi over 3? And in fact it is. So our phase shift is not pi over 3, our phase shift is actually 2. Not 2 pi, just 2. Okay, so let's see how all this works out. So let's go ahead and find each of our pieces for our transformation. So our amplitude is just that coefficient in front of 6. Next is our period. So our period is affected by that factor of pi over 6. So we're taking 2 pi and we're dividing by pi over 6. In other words, remember, we're taking 2 pi and we're then multiplying by the reciprocal of that, 6 over pi. So the pi's cancel out, leaving us with a period of 12. Okay, and that's what's nice about the phase shift of 2, is that you kind of want those to align. You want them to either both have pi's involved or neither have pi's involved. Okay, so then if we continue on, we have our phase shifts. And again, that is not pi over 3, it's what we get after we factor out that pi over 6. So our phase shift, that's negative, so we're going to move to the right 2 spaces. And then finally we have a midline, which is y equals negative 1. And whenever we have a midline, remember I like to go ahead and write down my range. So my range is the midline plus or minus the amplitude. So my range will be from negative 7 to 5. All right, so it's quite a big range. So we're going to be spanning both the negatives and positives. So we want to include that in my tick marks. All right, we have a little bit more in the negative range, so I'll kind of show that in my axes. Okay, so I don't have to put all of those tick marks because that's a lot of tick marks to put. Mainly, I just want to make sure that I kind of have the basic shape. So I know I'm going to be going down all the way to negative 7. I know I'm going to be going up to 5, so it's not quite the same distance that I show with my 7. And then I know my midline's at negative 1. So as long as you have those put on your graph, that's totally fine. Okay, so then I'm going to graph my midline with a slightly dashed horizontal line. And now let's graph our tick marks across the x-axis. So remember, we have a phase shift of 2. So just as a reminder, my phase shift is like my starting point. Okay, so my phase shift is where I want to start. And in this example, we're starting at 2. So when I graph that, I'm going to put a starting point of 2. And then our ending point is going to be 2 plus my period, which is 12. So I'm going to be ending at 14. But remember, another way that we can do that to get our tick marks is we can take our phase shift and add a fourth of my period, and that gives me every single tick mark until I get to it. So really, I'm going to be taking my phase shift of 2, and I'm going to be adding a fourth of 12, which is 3. And I'll put like 3n because that means I'm going to be adding 3 4 times until I get to my period. So 2 plus my first 3 will get me to 5. Add 3 again, and I'm at 8. Add 3 again, and I'm at 11. Add 3 again, and I'm at 14, which is indeed that 14 is the phase shift plus my period. So 2 plus the 12 gets me to 14. Okay, so again, that's how we get our 5 tick marks. Now that we have all our tick marks, now we just graph the shape of cosine. So cosine, we were not reflected across the x-axis. So cosine starts at its amplitude. Since we did not reflect, we're going to start at the top amplitude. So our starting point is at 2, and then for cosine, our amplitude is 5. So we're going to start at 5. Then we're going to come to the midline. Careful here, don't put your point on the x-axis. We're putting it on the midline, which is just slightly below the x-axis. Our next point, we're going to be at the bottom half of our amplitude, back to the midline, back to the original amplitude. And then make sure to draw your curvy cosine graph. And that is all of our transformations. Okay, so for our final example, and so this time we don't have a midline, but our phase shift is now the pi over 3. Notice that the difference from the previous example is that we already have this 2 factored out, so this is indeed the phase shift that we're looking at. So again, we're going to start off and we're just going to start listing all of our properties. So first of all, our amplitude is always the absolute value of that coefficient, so our amplitude is 1/4. So that means that our sine graph is going to be vertically compressed. Then our period is going to be divided by a factor of 2, so our period would be pi. Our phase shift, since we've already factored out that 2 inside the argument, this time it's going to be left pi over 3. And then our midline didn't change. It's still going to be at the x-axis. And then also let's make note, since we have negative, this is going to be reflected across the x-axis. Okay, since we don't have a midline, we're just going to have our amplitude, our points are going to go from negative 1/4 to 1/4. But let's talk about this phase shift for a second, all right? So we're starting left pi over 3. So our starting point, let's do this in another color. So our starting point is going to be at negative pi over 3, okay? And so then our ending point is going to be at that negative pi over 3 plus pi. And pi minus pi over 3 is 2 pi over 3. But I want to make sure that we get these points correct, and this is where we get a little bit difficulty in drawing our tick marks. So I'm starting at negative pi over 3, and remember, to get those 5 tick marks, you want to add 1/4 of the period. So I want to add 1/4 of the period. Well, 1/4 of the period is 1/4 of pi. So I want to be adding pi over 4. And I want to add pi over 4 times until I get to my ending point. All right, so here's where it gets tricky with adding fractions, because now we have different denominators. So this is how I like to do my fractions. So I'm going to start at negative pi over 3. I'm going to add pi over 4. So the first thing I want to do is get those in a common denominator. So I would have I have a common denominator of 12, so I would have negative 4 pi over 12 plus 3 pi over 12, right? So then when I add those, we get negative pi over 12. Okay, so that would be my second tick mark. So let's label that. So my first tick mark would be at negative pi over 3. Then when I add 1/4 of the period, we get to negative pi over 12. So that's my second tick mark. All right, and so what I'm going to keep doing is that second tick mark, I'm going to add 1/4 of the period again. Well, instead of adding pi over 4, I want to stay in the common denominator of 12. So I'm going to add 1/4 of the period again. So that's pi over 4, which is 3 pi over 12. And that would be 2 pi over 12. And 2 pi over 12 is pi over 6. So then that's my third mark. Okay, so you see how adding a fourth of the period is helping you to get each of those tick marks. It's just kind of tedious in making sure that we get each of those correct. All right, so that's my third tick mark. And so to get my fourth tick mark, I would take that 2 pi over 12 and add another 3 pi over 12. So 2 pi over 12 is just my third tick mark, right? From pi over 6, it's just the same thing as 2 pi over 12. Adding a fourth of the period again gives me 5 pi over 12. And that does not reduce. That's my fourth mark. Okay, and then to get my final, my fifth mark, we take 5 pi over 12 and we add 3 pi over 12 again to get 8 pi over 12, or 2 pi over 3, which we already knew that because 2 pi over 3, remember, is just simply my phase shift, negative pi over 3, plus pi, which gives me 2 pi over 3. So that's my fifth and final mark. Okay, so that's pretty tedious, but as long as you are just keeping adding a fourth of the period and stay with that common denominator, then you'll get all of your marks. Okay, so now let's go back and graph all of that. When we graph, we did not have a midline change, which is nice. So we're going to go up to 1/4, down to negative 1/4. Our starting mark is to the left pi over 3. So I didn't start this off really well because it should have gone to the left pi over 3. So we need to go over a little bit. And so notice that my first tick mark was negative pi over 3. My second mark is also negative pi over 12. That's quite a small tick mark. So I'm going to put that here, negative pi over 12. And then negative pi over 3 maybe is somewhere in here. Okay, now try to be good about equally spacing these apart. And so since I'm not centered around the x-axis, that's kind of difficult to do. But you kind of see how I have this space here, so you want to go that same space. And so that's my third mark, which was pi over 6. Same space again, that was at 5 pi over 12. And same space again, that was at 2 pi over 3. So I can see my 5 tick marks, make sure they're evenly spaced. They should each have a space of a fourth of that period, so pi over 4. All right, so my midline, again, is the x-axis, so we're going to look at the sine graph. And remember, sine always starts on the midline. So its starting point is at negative pi over 3 on the midline. It's negative, so instead of going up, sine graph is going to go down. So my next tick mark is at negative pi over 12, so it's going to go down and hit right here. Then back up at my next tick mark, up at my next, and back to my midline at 2 pi over 3. So this is about as difficult as it gets. It really doesn't get too much more difficult than this when we're graphing transformations of sine and cosine.